Hi, it's Chili here, and welcome back to lesson 2 of the game programming tutorial. Now, in the last video, I got you guys to download and set up our development environment and the framework. To type in this line of code, which just puts a pixel in the middle of the window, and finally, to figure out what each of these numbers controls in our program through experimentation. So let's go over that right now. We're gonna just build the solution as it is. One interesting thing to note is, if you remember, the first time we built the solution, it built all of these files: D3D graphics, keyboard, timer, Windows, game. But now it's only building game.cpp, and the reason for that is because we haven't changed the other files, so it doesn't have to rebuild them. It remembers the generated code from these ones, and it doesn't rebuild them again. So that's kind of smart. Computer, you so smart. Yeah, so good job, Visual C++. Keep up the good work. Alright, let's start debugging. And we got our white pixel in the middle of the screen. Let's try some shit out. So I'm gonna change the first number to 10. Oh, you don't have to click on build and then start every time. If you just click on start, it will rebuild it for you automatically. And holy shit, our pixel's gone. No, wait, it's over here. Okay. Phew. So it looks like that moved our pixel to the left. And likewise, if I make the number bigger, it's going to move our pixel to the right. So I think we can safely infer that the first number controls the horizontal placement of our pixel. And likewise, the second number controls the vertical placement of our pixel. Alright, now the last three numbers, they control the color. If I set these last two to 0, we can see that our pixel has changed to red. So to make a long story short, these three numbers control the color components of our pixel. First one controls the red component, second controls the green, third controls the blue component. The color components, the maximum value is 255 and the minimum is 0. If you go to 256, it will wrap all the way around back to 0 again. So 256 is actually 0. 257 is 1, etc. Last thing, let's go to 799 and 599. So this is 799, 599 is the bottom right hand pixel in our window. Likewise, the top left is at 00. So the horizontal component, or the x-axis, increases in this direction, and the y-axis, or the vertical, increases down, which is different than what you would normally see in geometry class. So yeah, in computer graphics, the y-axis increases downwards, and your origin is in the top left-hand corner. Also, screen size dimensions is 800 by 600. Alright. Now, one thing that might have happened while you were fucking around with this line of code is you might have entered numbers that go beyond the dimensions of our window. So let's enter 700 in here. So that's below the bottom of our window. And what happens when you do that is your program explodes with an unhandled exception. Yeah, sounds ominous. Access violation writing. So it was trying to write somewhere that it didn't have access to, namely below the bottom of the screen, which is bad, but not really that bad. It's bad for your program, but it's not that bad for Windows. Now if you try to continue, you can't continue. You just get Groundhog Day. So you click on break. And now you're like, what's happening? Because your window is all messed up. You can't click on your application. And you've got like some weird thing down here that says Otto's. My name is Otto, and I love to get blotto. Yeah. So what you got to do in this case is you have to go here. You find this little stop button. And this is the stop debugging button. And click on it. And stop debugging. Because we're not ready for that yet. We'll get onto that later. That's the debug mode, and it is very useful. It allows you to root around in the innards of your program as it's running. But for now, we'll just forget about it. So if your program crashes and you have to break, just find that stop button and click on it. It's not here in normal mode. You only get it when you're in debugging mode. Okay. Alright, so let's move on with some stuff. In this lesson, first thing I want to do is I want to just explain the different components of this line. So we know what this line does. It puts a pixel on the screen. Now this part of the line, the part that I've highlighted, this is called a function. Or actually, technically, it's a function call. We are calling a function. Now a function is kind of like a little magic spell. You put a little alakazam in there and it does some shit for you. It's like, hey, guy, get over here and bake me a pie. In this case, it's, hey, guy, get over here and put a pixel on the screen. So we type in put pixel, and then it does that for us. And that's what a function call is. It's calling a function. How we know it's a function, how will you know a function if you see one? They come in this basic format. First, there's the name of the function, and then it's followed by parentheses, and then it's followed by parameters or arguments. So you'll have like parameter 1 and parameter 2, etc. Then a closing parentheses. That's how we identify a function call. Now it doesn't even have to have any parameters. It can have no parameters. Look at these functions over here. These are function calls. You can tell because it has a name and then it has some parentheses. But there are no parameters. So yeah, parameters, they just they give more details about how the function should operate, how it should behave. So in the case of put pixel, these arguments or parameters here, they determine where the pixel goes and what color it is. Now this thing that comes before the put pixel, this GFX, this thing is an object. It is the graphics object of our framework, and it represents, or it encapsulates, the graphics subsystem of our computer. So actually, this put pixel function is a member of graphics. So when we want to access the put pixel, we have to first type graphics to say, okay, we want something from the graphics object. Then we type a dot, and then we type put pixel. So yeah, put pixel belongs to graphics. And finally, this semicolon here, this just says that this is the end of the statement. So this is how you show that it's statement over. This whole thing here is called a statement, by the way. Okay, so yeah, that's all I wanted to explain there, I think. I'll get into more details about functions and objects and stuff later on. But for now, I think we're good. We're good. All right. So for this lesson, we are gonna have more put pixel. Yeah, you can never have too many pixels. Let's put another pixel on the screen. We type GFX and then dot. Now notice this little thing that pops out here. I didn't mention it in the last lesson, but I'm sure you've noticed it. This is our friendly IntelliSense pop-up window. Now IntelliSense, what it does is it remembers shit for us, because when you program, you're going to have to remember, you're going to have to use a lot of function names, a lot of objects, a lot of just crap, and it's hard to remember all that crap. So what this does is it gives us a little friendly menu to pick from, so we don't have to remember the exact spelling of every single freaking function. So once we type graphics and then we type a dot, it will give us all of the members of the graphics object. So these purple thing, these boxes here, these are functions that belong to graphics. And these things here are data that belong to graphics. Now, forget about all that shit. All we want is put pixel. We can click on it and click on it, and no, double click on it, and it'll plop it down for us. Or we can start typing it out, and it will zero in on what we want. So I type PU and it zeroed in on put pixel. I could type out the whole damn thing, or I could type out the next character after the function name, which is a parenthesis, and it will complete it for us. That's auto completion. Very useful. Now, look at this thing here we got. This is also very useful. And whenever you type in a function call and you open up the parentheses, it will give you this tooltip, and it will tell you what arguments or parameters are required for that function. So it tells us the type of the parameter, and it tells us the name, which can give us a very good hint as to what the parameter is for, especially when you're kind of foggy in your memory about the function or whatever. So it'll give us the order of the parameters and the type of the parameters and the name of the parameters. So we see int x, so that means, oh, we're gonna have to type an integer in here, and it's x, so it probably means an x coordinate of the pixel. Alright, so we'll type in, what is our pixel going to be at? I think it's going to be, let's see, 400, so 399, 398, 765, 395, 395 by 300, 255, 255, 255. Okay. Let's just fix this one up here. Get back to our default state. 300. God damn you. Okay. Alright, so yeah. So that is IntelliSense, and it is very freaking useful. It's one of the main reasons why I program in Visual C++ Express, because it has good IntelliSense features. There are other integrated development environments with these features, but I can't be asked to find them or buy them or figure out how to use them. Okay, so what I'm going to do is I'm going to put a bunch of pixels on the screen. I'm going to type a bunch more put pixel lines to make a kind of image type deal. So when I come back, I'm going to have more lines of code here. Alright, I've finished typing in the lines of code here. I got 13. We now have 13 pixels altogether. So what I'm going to get you to do is I'm going to get you to type this in yourself, and then I don't want you to run it yet. The first thing I want you to do after you've typed it in, like this, is I want you to predict what kind of image is going to appear on the screen. So this is a little exercise in spatial visualization. So yeah, just try to look at the numbers, and from these numbers, imagine what we are going to be drawing on the screen. That's the first thing I want you to do after you've input the code. Now the second thing is, in this code there are 3 errors. I have purposely implanted 3 errors into this source code, and I want you to see if you can spot them. See how sharp your eyes are here. Yeah, and when you think you've figured out where the errors are, and you think you've figured out what the image is, then build it and see what pops up on the screen. So do that right now. Are you done? Alright. So let's see those errors. I think if we try to build a solution, the compiler will definitely let us know. Build. I will just build it like this. Alright. So this time we have, instead of succeeded, we have failed. Failure. And in the output, we get some errors. So if we look at these error messages, they can give us some clues about what the hell we fucked up. Alright? So, first error says PutPixel is not a member of D3D Graphics. That's strange because I could have sworn that it was. So, it tells us the line that the error occurs on, line 38. We could try to find that, but the easiest way is just to double click on the error. So double click on this, and it will take us to where it thinks the error is. So apparently, according to this, PutPixel is not a member of D3D Graphics. And we look at it, okay, PutPixel, this one's fine, but this one's no good. And yeah, so the second P is lowercase when it should have been uppercase. Herp-a-derp. Okay, so that should have fixed the first error. So let's just try rebuilding with that first error fixed. Alright, so that first error has disappeared. Second error. The PutPixel function does not take 4 arguments. Yeah, so we got 5 arguments here. 1, 2, 3, 4, 5. And here we have 1, 2, 3, 4. Oh, yeah, we missed the comma there. So, put the comma back, and now we should have 5 separate arguments. As things stood there, there were 4 arguments because the last 2 got fused into one single number. Let's build. Alright, so we're down to 1. Error. Syntax error. Syntax error. Yeah, that just, in plain English, that basically means programming. You're doing it completely wrong. So what's it say here? Missing a semicolon. Oh yeah, sometimes we do that. You forget those damn semicolons. Those slippery semicolons. Alright, so let's double click on it and see where it takes us. It takes us to this line. And we look at it and we say, hey, wait a minute, we got a semicolon here. What you talking about? You're crazy. You're talking crazy, man. But, yeah, it says missing semicolon before identifier graphics. So from the compiler's point of view, everything's going along fine, cool. We're doing our PutPixel, we're calling a function, and then all of a sudden we're calling another function in the same statement, and it's like, you can't do that. That's crazy talk. So from the compiler's point of view, the problem started down here. Everything was cool up until here, when you tried to call 2 functions side by side in the same statement. So we put our semicolon over here, and now everything is copacetic. So yeah, sometimes those error messages, they can be a little misleading as to where the actual error is. So you have to be aware of that. Alright, so now we built this mother, and I'm hoping you have already guessed what it looks like, have made your prediction, and have built it. And hopefully your prediction was correct. Now let's see if what you get is what I get. We should get the same image. Start debugging. And so yeah, what we get is a targeting reticule, or a crosshairs. And that's what I was aiming for. So yeah, just putting multiple pixels together, stringing them up one after another, and making an image. That's how you do it. Alright. So that's basically it for this lesson. I know we didn't cover any real new ground, but had to explain a bunch of crap, so that took some time. Now for a homework assignment, just a very a simple exercise. Just what I want you to do is take this targeting reticle, and I want you to move it over here. I want you to translate its position over to here without changing its actual the shape, the relative position of the pixels to each other. Just change the entire location of the targeting reticle over here. You know, just as some motivation, imagine some incredibly loathsome character right here, and imagine you're going for a headshot, and that should give you the motivation required to complete this task. It's not a big deal, it's pretty simple, but it'll be good practice in manipulating these numbers here and basic spatial awareness, whatever. I don't know.